All right, so welcome everybody to NE Bytes for the first event of 2021, so our February event. And today we're talking about serverless, microservices, and any other buzzwords that Matt can get into his presentation. For anybody who doesn't know anything about NE Bytes, just there's a couple of notes really. There's a few links there. The top one where we publish all our events. Anybody wants to reach out to us on Twitter or email, and there's anyone wants to see the code of conduct down at the bottom there. So comments, suggestions, ideas for talks, ideas for anything really. We're open to any kind of feedback. You can get me or Brett on Twitter or via that email. All kinds of different ways you can talk to us. So that's really all I've got to say. This month we've got Matt Webber, who's very kindly agreed to come and talk to us about microservices and stuff. So Matt is a tech lead based in the North East. He's AWS certified, and more importantly than that, he's agreed to come and talk with us tonight. So I shall hand over to Matt.
Right. Can you hear us okay, and can you see the screen?
See the screens and we can hear you, yes.
Yes, fantastic. Let's see how long it lasts, because it just seemed to completely freeze before. Right, I'll try that again. So this is an introduction to building serverless microservices. In this talk, I will cover using the serverless framework for building microservice applications, and all examples will be using AWS and Node.js. So generally, to start off, what is a microservice application? I know a lot of you will be familiar with that now because it's been a sort of concept for the last sort of 5 years. It's been very popularized. But generally, for anybody who doesn't know, a microservice architecture is the idea of designing your application via single function modules with well-defined interfaces and operations. It is considered an alternative to the more traditional monolith application. So generally, software built as microservices can be broken down into multiple component services. Each of these services can be deployed, tweaked, and then redeployed independently without compromising the integrity of the application. The microservices style is usually organized around business capabilities and priorities. It utilizes cross-functional teams rather than each team focusing on one specific thing, like UI, databases, or server-side logic. So microservices tend to use simple routing. They receive requests, process them, and generate a response accordingly. Generally, they're decentralized. So what I mean by that is rather than technology stacks being determined across the entire application, it is possible to allow each team to use their own tech stack. And also, rather than having a single database for the entire application, each service usually manages a unique database. They are designed to be fairly resistant. So in a monolith application, if something goes wrong, it can take the entire system with it. However, with microservices, if a single service goes down, it should allow the allow other services to continue to function. They're often also considered as a solution to an organizational problem. So they allow people to better align the application architecture to the organization. For example, assuming you use microservices across the stack, such as using micro front ends too, the organization will be able to divide into multiple cross-functional teams where each may be responsible for certain application features. One of the biggest disadvantages of them is they have all the associated complexities of a distributed system. So somebody who is used to monolith architecture will have to get much better at handling deployment, testing, and monitoring to unlock all the benefits. So what is serverless? So serverless is a cloud computing execution model that removes the need for you to run the server or manage machine resources. This is taken care of by the cloud provider. So pricing is based on a number of resources consumed by the application rather than pre-purchase units of capacity. And serverless often comes in the form of function as a service or backend as a service. So those being the two approaches, function as a service, this is when we carry out a function designed by the user, requiring little more than the code itself. So which the service then executes when triggered. So AWS Lambda or Azure functions are common examples of this. Alternatively, you've got backend as a service. So rather than just offering to execute users' code, this is a complete online service provided by a third party. A well-known example would be Google's Firebase that offers a fully managed and hosted database service. The benefits of serverless computing include lowering your costs by paying for only what you use. You never pay for over provisioning, and your resource utilization is optimized on your behalf. Rapid scalability, so serverless allows you to automatically scale from zero to peak demands quicker than ever. Allows you to focus on your application. So serverless architecture allows teams to focus on building features, therefore enabling a better experience for the user. And it also, kind of in the same breath, allows you to get to market faster by eliminating the operational overhead. So this will allow your teams to release quickly, receive feedback, and iterate. It's not a silver bullet solution, so there are drawbacks, some of which include, so it's not cost effective for long running applications. Serverless architecture is best suited for when you have lots of periods where your users won't or barely use your service. So spiky traffic patterns are key. If your application hasn't been used in a while and everything has been spun down, the first user that will hit your application will do so from a cold start, which means the request will take longer to be served as everything has to start up again. However, there are ways to mitigate that actually. So if you can predict when users will be most active, you can actually use something like an automated event to sort of warm up the functions ready for people to actually use your system. Another major disadvantage is there are vendor lock-in generally. So your application is completely dependent upon a third-party provider. You do not have full control over your application, and most likely you cannot change your application, change your platform or provider without making significant changes to your application. So what is the serverless framework? Serverless framework is a free and open source framework that makes it easy to develop, deploy, manage, and debug serverless applications. It supports multiple cloud providers, including AWS, Azure, and Google Cloud Provider. It utilizes function as a service to execute your business logic. So serverless functions need to have an event trigger. So using AWS Lambda as an example, it can be triggered by something as simple as a HTTP request, or something more complicated like another AWS service such as API Gateway or DynamoDB. The serverless framework uses a YAML file as well, so literally called serverless YAML. This is responsible for defining your serverless framework application and all associated infrastructure. And in that file, you can define the parameters for your cloud provider as well as each specific function that the service contains. So serverless framework also comes with a lot of plugins to help you add functionality to your deployment. So common examples include serverless upline for running your application locally, serverless webpack for bundling your JavaScript application, serverless TypeScript for if you want to develop your application with TypeScript, and many more. It's a very mature framework and well supported framework. So infrastructure as code, you have to use infrastructure as code if you're using the serverless framework. Application infrastructure is defined alongside the code that uses it. It creates exactly what you need with no extra redundant resources. It's not a new approach and exists already in the form of Helm for Kubernetes, CloudFormation for AWS, and Terraform, which is a cloud provider agnostic form of infrastructure as code. So historically, setting up IT infrastructure has been a very manual process involving setting up and maintaining a physical data center. Then along came cloud computing, which solved many of these problems, such as no longer having the need to rack and stack servers, thereby eliminating the associated costs, such as human and real estate cost. You could also spin up servers, databases, and other required infrastructure very quickly, which would solve the scalability and durability issues. However, there was still one problem. So through human error, the manual setup of cloud infrastructure can quite often lead to discrepancies. So this is where infrastructure as code comes along, and this solves the remaining problem by simplifying the process of defining your infrastructure, therefore reducing the potential for human error. The example I will show you later on uses CloudFormation, allowing us to automate the creation of our AWS resources. So going back to the serverless YAML file, so each of your serverless application needs its own serverless YAML file. So in the case of microservices, each microservice should have its own. For each microservice, this would contain information such as the service name, which serverless plugins to use, cloud provider information, what resources to deploy, function declarations, etc. You can also import or export within these files, allowing them to be split apart. This can be really useful for organizing your project. So using AWS as an example, one way you might want to split them apart is to put the AWS resource metadata or the CloudFormation script in one file, and then the IAM resource permissions in another. IAM resource permissions just being the, what allows one of your AWS resources the permissions to speak to another. And then these can be imported by the serverless YAML file, and this helps to prevent it getting bloated. You can also add things such as custom variables, which will be useful for tidying up the files. So when you have something like a large ID, such as an AWS resource ARN, that appears multiple times throughout the file, this could be something that allows you to stop having the ARN sort of referenced everywhere and just have it in one place, similar to just having like a constant in a sort of regular programming language. Ultimately, these files are really flexible and they can allow you to set up complicated cloud infrastructures. And at the end of this presentation, I will go over an example as part of an attempted demo. So are microservices always serverless? No, they're not. It's important to note that microservices aren't always serverless. So an alternative to serverless microservices is containerized microservices. Containers are the idea of packing your entire application and all of its dependencies into a dedicated box that can be run anywhere. So you can use this approach for microservices by containerizing each of your services using something like Docker. One key difference is generally containerized microservices run all of the time, whilst there are services out there like Kubernetes or ECS Fargate that can be used to automatically scale your containers. They should always have a base level of capacity, meaning the running costs tend to be higher as you'll be paying to run your services all the time, unlike serverless computing. There is, however, more involvement than with serverless computing, so administrative tasks involved to apply, say, security fixes for your containers. That is something that you have to do with containers, but you don't have to do with serverless, as the server's fully managed for you. Containers are generally a better approach if you have an application that will always be expected to run. So if this is the case, it will be cheaper to use containers over serverless, as you can pay via pre-purchased units of capacity rather than using the on-demand model that serverless uses, as this is more expensive if used all the time. So all or nothing, the use of serverless microservices are not an either-or proposition. It's possible to have only part of your application adopt this architecture. So this could be to support a longer-term transition to this architecture type from a monolithic application, if it makes sense to move the whole application, or it could be just that you've decided to move the parts of your application that you've identified as most suitable. So when trying to work out what is most suitable for this type of architecture, some things you could consider. So event-driven functionality, anything that is triggered occasionally by events, particularly those where the response time doesn't need to be instantaneous and can have up to a few seconds of delay. So rather than paying for this to run 24/7, it will be able to scale down to 0 when not required, allowing you to save on the costs. Scalability, so some parts of your application may have to scale more than others. For example, authentication demand might peak at certain times of the day, such as when people log in for the first time, whereas demands for other parts of the application might not fluctuate as much. Updates as well, so it's likely that some components of your app receive updates more frequently than others. So you could refactor that specific part of your app so that you can push out updates to it independently without impacting the rest of the application. So here are some use cases for serverless microservices. So you'll obviously be able to recognize the Netflix and the Coca-Cola logo. For anybody that doesn't recognize the middle one, that's CodePen. So if you question the potential of serverless computing, Netflix is a great example of where it's been used to a very large extent. So in 2018, they heavily relied on AWS Lambda to serve 7 billion hours of video to 50 million customers in 60 different countries per quarter. And one example was publishers are always uploading thousands of files to Netflix daily, and every bit of those files needs to be encoded and sorted before they end up being streamed to the user. So once the files get uploaded to S3, Amazon triggers an event called an AWS Lambda that splits the video into 5-minute chunks. These get encoded into 60 different parallel streams that Netflix needs. And once that last part of the video gets processed, they get aggregated and deployed using a series of rules and events. So this use case can take advantage of horizontal scaling of serverless and potentially even the cost-cutting benefits of the service being able to spin down during any idle periods, which is probably unlikely with Netflix, but for slightly smaller applications. CodePen. So CodePen, just to give you an idea of what they do, it's used to share pieces of code such as examples to help newcomers to learn more about programming. So in 2018, CodePen served up to 200,000 requests per hour, which was managed by a one-man DevOps team who took advantage of serverless computing. Before serverless, CodePen's architecture was based on 2 monolithic Ruby on Rails applications, the main site and another application dedicated to preprocessors. Both with a single relatively small database service. So issues they faced with this architecture included independently scaling only the necessary parts of their app when a particular code sample became extremely popular. And since their move to serverless, they've named a number of benefits, including being able to confidently serve up to the 200,000 requests per hour through an infrastructure that's managed by a single person. Significantly improved monitoring of their activities on CodePen, so making it easier for the company to make significant changes, and generally money saved from not having to get or manage their own servers. And finally, so back in 2016, Coca-Cola migrated to serverless to help them cut down on their costs. So at AWS reInvent, Coca-Cola's Michael Connor describes some of their use cases, such as their vending machines have an integrated communication system with their HQ. This is how the guys servicing the machines know if something is broken or running low on a beverage. So before serverless, this infrastructure was supported by 6 EC2 T2 medium machines on AWS that cost them $12,864 a year to operate. This included everything such as automation, elastic load balancers, management, security, etc. And the difference when they moved to the serverless framework, so adding up all of the costs for all the features they needed, it actually came down by roughly 2/3, down to about $4,490 per year. And this was calculated for the 30 million requests that they were getting at the time. So to help you gain a better understanding of what a serverless microservice application might look like, I've gone ahead and built the backend for a simple booking application. The application is written in JavaScript and powered by Node.js. So via the serverless framework, it is then built and deployed on AWS through a single command, and it uses CloudFormation for our infrastructure as code. The application has 3 distinct services. An auth service, which is responsible for authenticating requests using JSON Web Tokens. A notification service, which is responsible for pulling notification requests from an SQS queue, and then sending an email to the specified recipient using AWS SES. And a booking service, which is responsible for creating the bookings, listing the bookings, closing the bookings, and sending reminder or thank you messages to the SQS queue, ready for the notification service to pick them up and send an email or message accordingly. So what the application does, the application, like I said, it's a very simple booking application that allows people to view what times are available and book their appointments accordingly. So 24 hours before your appointment, it will send you a reminder email to let you know about any upcoming appointment. And once your appointment has passed, it will automatically close your appointment and send you a thank you email. So the application is suitable for serverless microservices because, one, it's hard to predict exactly when people are going to book appointments, but it's reasonable to assume that requests won't be incoming 24/7. So this means that costs will be massively reduced by using an on-demand pricing strategy. Periodic events such as automatically closing appointments once they've been completed, sending an email to remind somebody of an upcoming appointment, or sending an email for a thank you after an appointment is closed, can be easily automated with very little effort. as mentioned earlier on in the presentation, so one of the downsides of this approach is the potential for cold starts when somebody sends a request to the application for the first time in a while. This, as I said earlier, can be somewhat mitigated by monitoring what periods your application is most active in, and then setting up automated events to ping the service to keep it warm during this time. It won't eliminate cold starts entirely, but it will reduce the number of users who will experience one. So a little sort of architectural diagram just to explain how the application works. So basically, the booking service exposes a set of endpoints through API gateway. These would then be consumed by either a web or mobile application over HTTP. All endpoints are protected by the auth service. This service speaks to our third-party auth provider, Auth0, to determine if the provided JWT is correct. If correct, it will return, it will permit the request and respond in kind, and if not, it will reject the request and respond with a 401 status code. The JWTs are provided by the Auth0 sign-in page as well, so that's a fully managed service. So in this service, we have two publicly exposed endpoints. So you've got create booking, which will simply take the request body, validate it, and if appropriate, create a new booking in our DynamoDB table. We also have a list bookings endpoint that is responsible for reading the DynamoDB table and returning any outstanding appointments to help determine what times are still available. We also have a function called process booking. So this is periodically triggered by a schedule event. It will then check the current information and determine if any actions need to take place. So these actions could be closing an appointment, sending a thank you email, or sending the reminder email 24 hours before the appointment. We'll also update the DynamoDB table to mark that a reminder or thank you email has been sent, as to not send the same notification twice. Anytime the process bookings function determines a notification should be sent, it adds this to our SQS queue. This will then trigger our notification services send mail function that will then pull the request from the queue and send the notification via SES, which is just simple email service. So how to deploy the application? You can deploy it. You can deploy an application that makes use of the serverless framework via the command line. So if deploying the application for the first time, or if already deployed, but where the serverless YAML file has been changed, e.g. the infrastructure needs updating, you can just run sls deploy-v. If only a single function needs updating and there are no infrastructure changes, you can deploy that by itself using sls deploy-f, your function name -v. The -v stands for verbose and allows you to see everything that happens during the deployment, so it makes any errors a lot more visible. And of course, you will have to install the serverless framework in order to get access to these commands, but these can just be installed simply via npm. So how to debug and monitor the application. So when working on a serverless framework application, there are various different approaches you can take. Deploy all of the application to your chosen cloud provider and use either logging or other monitoring approaches. Use the serverless offline package or use third-party dashboards for monitoring your application. So third-party dashboards tend to be in tandem with option number one. It just means rather than looking at it through CloudWatch, it's a lot easier to see what's going on. So with the serverless framework, it's very commonly used to just deploy the functions and work with deployed versions of the application. So this is because deploying is made very simple due to infrastructure as code. The free tiers that are available with the main cloud providers, such as AWS, Azure, and GCP, tend to cover everything, meaning the cost of doing so is very cheap, if not free. It's much easier to do this when your architecture involves other cloud infrastructure as well, or services such as an SQS queue. So rather than actually setting up everything locally and then having to set up all the third-party stuff, such as a queue or DynamoDB instances, etc., you can just rely on sort of the deployed infrastructure. If you do prefer to host your application locally, there's a package called Serverless Offline that allows you to do that. So with all that said, though, scrolling through your logs, either via something like AWS CloudWatch or the command line, can be a really painful experience. So using the third-party offerings that I've just mentioned before, some of which are free, can massively improve this experience. So for example, with AWS, you can use something like Dashboard, and with this, you can parse and analyze the logs from all functions in your system on the account level. Errors are highlighted. You can see the overall health of your system. It can even track the cost so you don't blow your budget. And how to test the application. So always start with unit tests, whether or not your code base is serverless. So for integration tests, set up a dev stage for all your application infrastructure, so databases, buckets, etc. That your code base will use during the integration tests. You'll also need to have some event mocks prepared for all your handlers. So depending on the type of event the handler is expecting. And you can sort of test things locally as well. So you can use serverless invoke local, which will obviously run the function locally. But you can also do serverless invoke, which will allow you to sort of test your functions remotely as well. So generally, with a unit test, your handler should always be a thin layer that uses modules out of your code library. So if those modules are well covered with unit tests, then testing the serverless part of your application, mainly the handlers, will be easy during the integration tests. With the integration tests, since you'll be interacting with the actual infrastructure pieces in your application, you'll need to make sure you stage your application during development. Dev is the default stage. It will be the one I'll be attempting to use in the demo sort of next. And it's also the default stage when using any sort of serverless framework application unless otherwise specified. An example as well for integration tests for the event mocks could be if you use your serverless application. Sorry, if you have a serverless function which is subscribing to something like an S3 event source, you need to make sure you have a JSON file that mocks the S3 event that AWS sends out. You can get that by trying it out yourself only once on AWS, and then you can store that somewhere for future reference. And it is also possible to test functions on an individual basis by invoking them locally using the serverless invoke local command. You will need to provide the function you'd like to invoke and an accurate event mock. So while the invoke local command doesn't emulate Lambda 100%, you'll still be able to find issues in your code base quickly without having to wait for an actual deployment. So with remote invocation, after testing and debugging your serverless application locally, you probably feel confident enough to deploy your application at least to the dev stage. So you can then test your functions using the serverless invoke command, but keep in mind that the local environment is a bit different than the actual deployment environment. So AWS Lambda limits don't apply locally, so you'll need to be careful to make sure that you won't be hitting any of those limits on deployment. Using multiple stages is a great way to have more confidence about your tests. So you can have a QA environment that's an exact replica of your production environment. So since they're running on the same infrastructure, this can ferret out any hidden bugs you might miss when developing locally, such as issues with Lambda functions IAM permissions or limitations around Lambda. And just like local testing, you can pass a mocked event to the serverless invoke command to test your deployed functions. But even better, now that your functions are actually deployed, you have the additional option of triggering the real event as well. So that covers everything pretty much and takes us quite nicely into the demo. So let me see if I can share my application. Right, I'll just have to stop sharing while I change the screen quickly. So I'll start here. So just to I know I've spoke a little bit about the serverless YAML files. This is an example one. This is the one for the application booking microservice. So we'll start from the top. Basically, the most obvious thing, you've got the name of the service. You go down, you've got the plugins that you want to use for this serverless application. So in this case, I've used sort of serverless bundler for bundling and serverless pseudo parameters, which can kind of be like in the string interpolation. It's a good way of sort of referring to different things like your custom variables, etc., across your serverless YAML files. Underneath, you've got the cloud provider information. So again, in this case, with us using AWS, you can see AWS at the top. There's information about the runtime, memory size, what stage we're deploying to, region, a couple of sort of environment variables and stuff, which will be actually used by the application. And then what you can see underneath as well is the I am role statements. So what you'll see is actually they are imported from another file. So this goes back to the fact I was saying you can actually split up the serverless YAML files. I'll show you an example of that under resources though. So under resources, there's a single AWS resource created alongside the booking application. This is a DynamoDB table. So if I jump actually to the booking service folder, we should be able to. Yeah, so this is just the metadata or CloudFormation script for the DynamoDB table. And as you can see, that's just imported from the serverless YAML file and just keeps it a bit tidier, prevents the file from getting too bloated. Underneath, you have your functions, which you have to define. So there's a couple of HTTP functions. You can see the create booking one, which is just a post. Requires a post HTTP method. You sort of specify which handler it uses as well, which is basically just which handler in the code. For get bookings, likewise, but this time it's a get. And for process bookings, it's slightly different on this one. We're still deploying a Lambda function, but actually this is invoked by an event. So every 5 minutes, this will be called. It'll spin up the function and it'll just check to see if it actually needs to do anything. So going back to what I was saying before, that could be anything such as sending a reminder, sending a thank you, closing requests, etc. And underneath, you've got the custom properties as well. So if we go back up to the HTTP functions, you can see each one has an authorizer. So this underneath, we've got the ARN of the auth service. And what I've done is just put that into a custom variable and I've referenced it from here. So rather than having to put the entire ARN each time, this just tells that this function, before it can actually be triggered, you must pass the authentication that is sort of managed by the auth service. And if you don't, you'll just get a 401 request. So that's kind of it. There's obviously a few more things, but these are just references from elsewhere and can be used again further sort of within the serverless YAML file. So what I'm going to attempt to do, and we'll see how nicely this goes, is to actually do some live sort of infrastructure as code. So right now, the application isn't deployed at all, so there's no stacks up in CloudFormation. So we're deploying it for the first time. So when deploying it for the first time, you can just run the SLS deploy-v, which will kick off the services. I'll do that for the notification service, the auth service, and I'll have to wait a second for the notification service to build itself a little bit, just because actually the booking service has a dependency on it. So if you try and deploy them at the same time, they can conflict. But what I will talk about in the meantime is actually what you can do is, so like I mentioned before, if you haven't changed the serverless file and everything's already deployed, you can actually deploy your function. So rather than having to wait for everything to deploy every single time, you can just deploy a specific function. So if I wanted to deploy the process bookings function because I've made a change to the code, you can just do that by specifying -f, then the function name and -v, and that would actually deploy that on its own. And then I'll kick off the deployment for the booking service as well. So rather than sit and wait for all of these to load, I'll just change over the screen to Chrome and I'll actually show you through the AWS console. So again, let me just change the screen. Try that again because it didn't actually share the correct screen. There we go. Can you see the screen? Can you see AWS console at the minute?
Yeah, we can. Yeah.
You can. Cool. Right. So if I jump into CloudFormation, hopefully these have all spun up. So the Interestingly, the delete from a previous deployment is still fragmented there. You can see the auth service is deployed okay. Let's have a look. So you can actually see within CloudFormation actually where it is. So the notification service hasn't kicked off, but the from what I can see, the auth service has. I'll reattempt it with the notification service. That might have also caused the booting service to fail as well, because that has a dependency on the notification service. But let's check. So the reason the notification service is failing is because the delete failed previously. So naturally, you test this earlier, it goes fantastic, and then when you do it, it's actually fragmented. So let me just try and delete this. Okay, so we've got a booting service, we've got a notification service, and I'm just trying to find out why exactly that is failing. So
you need to delete the serverless deployment bucket.
Yeah,
you won't be able to delete it because it's not empty, so you have to manually go and delete that bucket and then do it again.
Yeah, I've run it a couple of times earlier. I never actually encountered the same issue, but yeah, I'll go empty the bucket. So the auth service, notification service. Jump back to CloudFormation, that should delete quite nicely now. There we go. Right. So sorry for the delay there. And let me just redeploy the notification service. Fortunately, there's not too much to actually deploy for that, so it should spin up fairly quickly. And in the meantime, I'm going to set up. So I've set up a Postman environment, so where we can kind of see how the requests and stuff will go across. And just get the new URL because it generates a new one every single time you deploy. And so how's the booking service gone up? Notification service. Looks a bit more promising. So if I just change the booking hosting here to the new one, and let's see how this will go. Just wait for that notification service to spin up. Can you see Postman?
Yes, we can.
You can, great. So what I'll try and do is just because I actually generated a new token earlier. So to actually get access to these, obviously the auth0 authorizes sits in front of each endpoint. So I'm hoping the tokens stayed active. There we go. So you can see there's no bookings in the database at the minute. If I go ahead and create a booking for so the 19th of February, tomorrow at 9 AM. and go ahead and create that. We should get a booking ID back. So that's come across now. We can see if I actually show the list bookings. So this will show the actual bookings. So you've got to think this will be consumed by a front-end application, which if somebody was booking for the first time, it will show them which slots are available and which ones are taken. And now that that's in, what I'm hoping for is we should be able to get a nice email sent actually by the process bookings function, which spins every 5 minutes. But rather than make you sit there and wait for 5 minutes, I'm going to invoke it locally, just so it'll trigger straight away. So you can do that by SLS invoke -process bookings -v. But before I do that, I'm just going to make sure the notification service is deployed. It looks like it is, which is great. So there you go. You can see the request from the process bookings. So a reminder's been sent. And what I'm hoping is to get a nice little email on my phone telling us the email has arrived, and it has. So if I log into the email address that is subscribed to the token, so you can say we've just received an email. We're emailing you to remind you that you have an appointment booked for 9 a.m. on, it's an Americanized date. Sorry for that. Disgusting. On the 19th of February. So yeah, that pretty much is it. It's a simple enough application, but it kind of shows in a few different microservices how they can speak together, how they can sort of be triggered by different mechanisms such as HTTP, SQS queues, and so forth. So if I go back to the presentation now, there's one last slide, and it's pretty much just asking if anybody has any questions. So feel free to start asking them while I sort of bring the presentation back up.
So Matt, normally I wouldn't expect people to be deploying these from command line. Do you use things like Azure DevOps? Because I know that's what we do. And one thing that we use is we use nested stacks. So it just makes it easier just for kicking one off, which does all the other ones.
So generally for this demo, I've done it via the command line, but if you had a more sort of complex application, you can build a command into your pipeline. So that can be automated. You could do it so through AWS, for example, you can just use sort of code build and code deploy to manage it, so it's fully automated. You wouldn't be expected to type this in every time, but for the sake of a simple application, you can do it from the command line.
Yeah, we kind of do both. So we've got a continuous integration that builds and deploys whenever anything's checked in, runs all the tests, etc. But if I'm developing locally, sometimes that can take a long time. So what I'll tend to use is I tend to use PowerShell to deploy stuff when I want it. And as you said, it's only if you've got kind of infrastructure changes that you really need to deploy it. But I've never kind of deployed just one bit at a time. It's either kind of I need to deploy or if there's an infrastructure change, I need to do all of it. But I can't really see a way of doing a little bit of the infrastructure.
Yeah, it depends on what it is really. So one of the, in the last sort of 2.5 years, I've actually been in a company, we've been working on a sort of startup, and that had a workflow engine. So when you have something where there's only a couple of different functions and stuff, and you just want to sort of not deploy it quickly and test that quite quickly, you can do it there. If there's 5, 10, 20 functions and they're all speaking to each other, it's not going to be more efficient to just keep running, deploying the single functions. You can run them locally if you want to just test them and stuff. Does this actual logic make sense? You can obviously verify that with something like a unit test or an integration test. But if you're actually trying to bring your whole application together, and it is a very complex application, then sometimes deploying the whole thing is just kind of, there's no real way of getting around that. Does that answer the question? Sorry.
Yeah, cheers. It was just more of an observation of what we do. I mean, we have all of the unit tests and integration tests, which I tend to run locally before I check them in. But then when you've checked it in, it's going to run it all again anyway. I think one of the biggest things that helped us really with the unit tests is interfacing absolutely everything. so
Yeah.
that you can just kind of mock everything on each step. I really found that quite useful.
Yeah, I think where we used it in the past, we sort of start with test-driven development, which just naturally allows everything to be as testable as possible and stuff for the unit tests. We right now I've actually just started on a project, which I can't go too much into the specifics, but the technical side of it is it's quite a legacy project with very few unit tests, and we're actually doing it so from rather than approaching it from a greenfield side. We're having to sort of do a strangle approach and bring things over, and we're actually trying to refactor a lot of it to make them a lot more testable. And that's a .NET application as well, actually, sort of in the back end. So that could be a good approach for that project.
Yeah.
Anybody got any other questions?
Are you delivering the pizza, Graham, yourself, or?
No, it's all virtual this time, sorry.
Virtual pizza, now I've heard it all.
Matt, I had a question.
Sure.
You mentioned about vendor lock-in earlier on.
Yeah.
Have you thought about any ways to sort of mitigate that?
For serverless so far, it's not something I've actually investigated too much. For more container-based microservices, so actually the use of Kubernetes, you've got Kubernetes for your sort of containerized microservice infrastructure, and for managing that and sort of scaling it out, etc. So that's a way where you can take it quite easily from, say, Azure to AWS. You've also got, I guess, on the infrastructure as code side, you've got actually the use of Terraform. So that's another kind of open source one that's maintained by quite a few people. If you build Terraform for AWS, the same sort of scripts should. I mean, I'm not a DevOps guy. I'm a developer that has dabbled in DevOps, but should work on another sort of cloud provider. In terms of the serverless stuff, I'd have to get back to you on that.
Okay, thanks. Anybody else?
Cool.
Oh, it's all very quiet. Okay.
Cool. Okay.
All right. Well, thanks very much, Matt, for coming and giving us some of your time to talk about this.
No problem at all. I was actually quite happy that it went all the way through, because I just had pictures of Teams crashing out again and me just presenting the entire thing to nobody. So I'm quite happy that it actually worked in the end.
I had my fingers crossed for you. Yeah.
Yeah.
Excellent. Okay. Well, thanks everybody for attending. Keep your eyes open for announcements of the next event, and we'll see you in a month's time or so.
Yeah, thanks very much. Cheers, Matt.
Sound good. Cheers.
Cheers, bye.
Bye,
Derek. Bye.